Hippos can't swim. Rather, they sink and walk. This is partially due to their weight, as they are some of the heaviest land animals on Earth. Elephants are one of the few heavier land animals, and they can swim and float. Why is this? Well, to understand this, you have to take into account the weight and volume of the animals. So if we look at an average elephant and hippo, the elephant is about 50% heavier than the hippo, but it also has about 150% more volume. Now we can introduce Archimedes' Principle, which postulates that the buoyant force has a magnitude equal to the weight of the fluid displaced by the body and is directed vertically upward. In other words, the buoyant force is equal to the weight of the fluid that it displaces. So even though the elephant is heavier than the hippo, its volume is that much greater that it's able to displace more water, allowing it to float. We will now prove this principle with some at-home experiments.
In this first example, we will demonstrate the effects of volume on buoyancy. Rocks are a good example of a dense object that have a small volume and sink, but if placed in a container with a larger volume, will now be able to stay afloat. You can even add even more than just the rock to it. In the next experiment, we will show that the water is supplying an upward force which will match the weight of the fluid displaced. We'll start by filling the container of water to the top so we can then weigh the fluid that is displaced. Start by zeroing out the weight of the duck so we can see the force of the water on the duck when we place it in the water. You can see here that once we place it in, we get about 25 grams is the force that the water's doing on the duck. And then when we remove the water, you'll see that we have about 23 grams of water.
For our next experiment, we are using maple syrup, which is about 40% more dense than water. As you can see on the scale, the syrup is producing a buoyant force of 35 grams on the duck, which is exactly 40% more than the 25 grams of force from the water. So now you know that the buoyant force on an object is equal to the weight of the water it displaces.